Scientists say they have proven the existence of gravitational waves, the ripples in space-time that stem from objects moving throughout the universe. If true, it's the first time these waves have been measured directly and marks one of the biggest scientific discoveries in decades. The discovery was made by the large group of researchers who make up the Laser Interferometer Gravitational-Wave Observatory (LIGO) scientific collaboration. The LIGO observatories picked up the wave signals on September 14, 2015, coming from two distant black holes merging 1.3 billion years ago. The black holes spun around each other several times per second before merging in a massive explosion, a process that generates huge gravitational waves. These waves peter out on the way to Earth, requiring delicate instrumentation that must adjust for any interference on our planet. Though LIGO's observations are groundbreaking, other scientists will need to pore over the data to make sure it's correct. The study was published today in Physical Review Letters. There will also be more studies in the coming weeks and months. Gravitational waves were predicted by Albert Einstein in 1918, as part of his theory of general relativity. Finding them would confirm a big part of that theory, and would also be the first step toward a new way of observing the cosmos. Black holes and neutron stars are too dim to be seen by modern telescopes, but researchers might be able to measure the gravitational waves they produce. That would tell scientists more information about how these objects manipulate gravity, and may even lead to the discovery of new objects and concepts we've never even thought about. It's not just that we're checking on a theory, says Ira Thorpe, an astrophysicist at NASA, who was not involved with LIGO. The real important part of this is it gives us a completely new tool for understanding our universe. Einstein's theory of general relativity altered our understanding of gravity. According to Newtonian physics, all objects in the universe are innately attracted to one another. Einstein instead proposed that objects actually warp the space-time around them, creating gravitational pull. Imagine a bowling ball on top of a stretched blanket. The ball bends the blanket, creating an impression in the fabric. Planets and stars are the bowling ball, space-time is the blanket. Now, imagine rolling a marble across that blanket with the bowling ball on it. The marble is going to follow the curve of the blanket down toward the ball. Smaller objects like asteroids act like the marble when near a bigger mass, they following the curvature of spacetime the larger object creates. When objects move through the universe, they also warp spacetime as they go. This causes ripples, gravitational waves. The movement of every object, from a person to a supermassive black hole, produces gravitational waves. The more mass an object has, the bigger the wave it produces. Superdense objects like black holes or neutron stars moving at rapid speeds can produce big enough gravitational waves that can be measured here on Earth. So that's what LIGO's scientists targeted.
We can hear gravitational waves. We can hear the universe. So what we have done is taken the real signal and shifted a bit in frequency, but it's still the real signal. Did you hear the chirp? There's a rumbling noise, and then there's a chirp. Let me do that again. Whoop. That's the chirp we've been looking for.